Okay, so before we get started, you should probably have a background in integrals and derivatives for this, but we're just going to be explaining how distance, velocity, and acceleration are related. So let's just say we have a ball, and it's rolling on a desk. This is our desk right here, and the ball is rolling. And slowly, it's getting faster and faster. So we're just going to plot this as distance. So let's say this is our distance, our y is our distance, and our x is our time. So over time, the ball is getting farther and farther across the table, right? So we can just draw it like so. And the reason that it's sloped like this is because as time goes on, the distance per time is going to get faster and faster, or the velocity is going to get faster and faster. So how does this relate to velocity? Well, if you were to take the derivative of this function, so I don't know what this function is, but if we were to take the derivative of it, let's call this function f of x, and we were to take the derivative of it, so f prime of x, then that would be our velocity. And why? Well, you can imagine that this is our distance, this is our time, and what a derivative is basically the y over the x. So it's distance per time. And distance per time is the same thing as velocity. So v prime of x would be your velocity. I'll just write a v to represent velocity. So now let's draw another graph. So then the velocity is increasing. So this would be velocity and this would be time. So over time, velocity is increasing. So it's getting faster and faster as time goes on. So what happens if you take the derivative of this? Well, that would be, so f prime of x is this function, right? So we were going to take the derivative of that, so it's going to be f prime prime of x. And that's going to be your acceleration. So why is that your acceleration? Well, again, taking the derivative of something is basically saying y over x, and in this case our y is v, and in this case our x is t. So it's saying velocity over time. So how much is velocity increasing as time goes on? So then we can rewrite, so then we have acceleration. And we can rewrite acceleration as distance over time squared. Because you're basically saying distance over time, and then you're dividing it by time again when you're taking the second derivative. So this is how they're all related: distance, velocity, and acceleration. So, and if we were to draw acceleration on a graph, it might look like this. And you can keep taking derivatives to get, say, the acceleration of the acceleration. So what is that? Because that sounds complicated. So the acceleration of the acceleration, if we were to take the derivative, and that's the third derivative of distance, would be the acceleration as time goes on. So that's how much the acceleration is actually changing as time goes on. So if the acceleration is changing as time goes on, that means that velocity is going to get faster as time goes on, So that just means that the acceleration is actually increasing. So the velocity is not only getting faster and faster, it's getting faster and faster at a faster rate. Saying faster a lot, but yeah. So this is going to be the connection between distance, velocity, and acceleration. And you can keep going, saying oh, acceleration is increasing more and more and more. So, and that just means that as time goes on, acceleration will increase. And then maybe even the acceleration of the acceleration will be increasing as time goes on. So you can see, using graphs in calculus, we can actually relate distance, velocity, and the acceleration of acceleration. So, Khan Academy has some good videos on this as well. So, if this was confusing at all, I suggest going on to Khan Academy and just look up Khan Academy. It should be the first thing that comes up. Yeah, that's pretty much it. Thank you.